Hello students. So far we've solved systems of two equations with two variables, and we've used graphing, substitution, and elimination. We're going to be moving on to solving systems of three equations with three variables, which are going to be a little bit more complicated. Let's consider two examples. First, let's look at the system of equations that's made up of x minus 2y minus z equals 1, y plus 2z equals 5, and z equals 3. And then we'll also consider the system of equations x minus 2y plus 3z equals 1, x plus 2y minus z equals 13, and 3x plus 2y minus 5z equals 3. Each of these is a system of three equations with three variables, but one of them is much simpler to solve. Can you figure out which one is more simpler and how we can solve it? Well, the first one is actually fairly simple to solve, and we can solve it using substitution. We already know that z is equal to 3. We can substitute that into the second equation and then solve that for y. And once we know the values of z and y, we can substitute them into the first equation and find x. This is relatively simple. Let's actually do this. When we substitute in 3 for z in the second equation, that becomes y plus 2 times 3 equals 5. We know that 2 times 3 is 6. And when we subtract 6 from both sides, this gives us y equals -1. So we know what z and y are. Now we can substitute those into the first equation to find x. We've got x minus 2 times y, which is -1, minus z, which is 3, and that equals 1. Here, a negative times a negative is a positive, so this becomes x plus 2 minus 3 equals 1. 2 minus 3 is -1, so this becomes x minus 1 equals 1. And if we add 1 to both sides, we end up with x equals 2. So our solution is x equals 2, y equals -1, and z equals 3. The other system of equations is not as easy to solve because there aren't any equations where we have only one variable that we could easily use to substitute into the others to solve. Now, we have a name for systems of equations that are set up in this first method. This is called triangular form. So this form is triangular form. And the reason it's called triangular form is because if we look at the terms that we have all lined up, they fit in this triangle on the upper right side of the system of equations. With the other one, unfortunately, it's not in triangular form because in addition to those terms, we also have 3 other terms that are outside of the triangle. So our goal is going to be to get each of these systems of equations into triangular form. And to do that, we're going to use a modified form of the elimination method. Remember that the thing that the elimination method was good for was eliminating individual terms in our system of equations. And if we want to get these into triangular form, we need to be eliminating the 3 terms in the lower left-hand corner. But what we're going to do is we're going to talk about this a little bit differently, and we're going to look at the things that we're allowed to do. There are 3 things that we're allowed to do to try and get these into triangular form, and we call these three things row operations. So we're going to go through these row operations one at a time to make sure that we understand what we're allowed to do. And then in the next video, we're going to use them to solve this second system of equations. So let's take a look at the row operations. So the first row operation that we're allowed to do is we're allowed to add a multiple of one equation to another. This should look somewhat familiar from elimination. Remember that we could multiply an equation by some constant and then add it to another one. Here, that's exactly what we're doing. We can add a multiple of one equation to another. And we could just add one equation to another without doing any multiplying. But this tells us that we can add any multiple of one equation to another. The next thing we can do is we can multiply an equation by a non-zero constant. And the third thing that we can do is we can interchange the position of two equations. So using these three row operations, we can transform a generic system of equations to one that's in triangular form. And once we've done that, we can use substitution to solve for the variables. There's a name for this process of getting a system of equations into triangular form, and this is called Gaussian elimination. And it's named after the mathematician Gauss. It ends up being very, very useful. And in the next video, we will use Gaussian elimination to get this second system of equations into triangular form, and then we'll finish solving it using substitution.